You're going to write console applications because they're simple, but our very simple Hello World application had quite a few lines of code, and I'd like to actually go through them now and explain them to you in turn. It started with a comment. Comments in C++, when they're on a line of their own like this one, start with the 2 slashes. And this comment was actually generated by the Visual Studio wizard that made the project, and you'll see a little bit more about that shortly. Any line that starts // you can ignore it, it's a comment. Then we had these 3 what are called preprocessor directives. C++ has something called a preprocessor, which goes through your code before the compiler and tweaks it a little bit. And one of the things that it does is it combines multiple files into one. If there's some functionality that you use routinely, you put just the definitions of that functionality in what's known as a header file and include that header in each file that needs it. Often, when people first meet this, they think it doesn't make any sense and doesn't have any value because they're seeing very small applications where everything could fit in a single file. But it can be very useful for larger structured applications that have perhaps hundreds of functions that need to be used by some parts of the application but not others. You can use header files to keep this all straight and to make it all make sense. The symbol at the beginning of these lines is pronounced differently by different people. You might hear hash, you might hear pound, you might hear number sign or just number. What I hear the most often is nothing at all. People will just read these lines as include standardafx.h, include iostream, include string. They don't even pronounce the symbol. You may notice that the first line has double quotes around the file name, and the other 2 lines have angle brackets. As well, the first line has a .h, and the other 2 lines do not. This is deliberate, and it actually makes sense. The double quoted line is referring to a file that is part of the solution we're compiling, and I'll show you that in a little while in the demo. The angle bracket lines are referring to parts of the standard library, functionality that comes with C++. As a cross-platform language and something that's controlled by a standards committee, there was an interesting dilemma to be solved when these headers were being named. It's very common on Windows to say .h for your header file. But some people who have a C background and were using .h for C header files like to use HPP for C++ header files, just as we use CPP for the source file of a C++ program. Rather than settle the issue of whether they should be called something .h or something .hpp, the standards committee made the standard library includes not have any extension at all. So it's just iostream or just string. You may find some really old code if you have an old book that uses extensions on their standards library headers. Do not pay attention to that book. It is too old. It's been very much the case for a long time that there is no extension on a header include. So these 3 lines include one header from elsewhere in our project, pronounced standardafx.h. You pretty much always pronounce std as standard in C++ land. And 2 headers from the library, one called iostream and one called string. And between them, these headers provide some of the definitions that the rest of the application is going to use. This line declares the main, the entry point, the thing that is run when you run the application. So when you run this application by choosing Control F5, Windows does some loading, does some bits and pieces, and then hands control to the start of this function. You may read again in elsewhere that your program is always called main. This T main actually gets translated by the preprocessor into main. It's kind of a long story. This is what the wizard will generate for you, and this is what's right when you're working in Visual Studio. Then we have a brace bracket. Says here T main starts, and everything that follows is in that T main until we hit the close brace bracket that ends it. This is the line of code that caused type your name to appear in that black DOS box or command prompt when the application ran. The way you read this is standard cout. The symbol in between them, which you get by typing a colon twice on your keyboard, is known as the scope resolution operator. And scope resolution operator shows up in a couple places, but one of the really important ones is between a namespace name and something that's in the namespace. And cout is in the standard namespace. Specifically, cout stands for console output. So I'm using a standard capability that comes with the language to put output on the console. Not surprisingly, after a little bit of punctuation that I'll explain later, you see type your name, and type your name is what we saw appear on console output. Then we have, again, the symbol that I'll explain later, and standard ENDL, which everyone I know pronounces endline, because that's what it stands for. And that's what caused the cursor to sort of move down to the next line for me to type my name on. And then there's a semicolon because our lines end with a semicolon. Preprocessor directives like the includes didn't end with a semicolon, and the function definition didn't end with a semicolon. Braces are all on their own. But this is our first kind of real line of the application, so it's ending with a semicolon. This line declares a variable. As in a lot of languages, we say the type of the variable, and then one or more spaces, and then the name we want to give it, and then in this case we end the statement with a semicolon. So the type of this variable is std : string, which is generally pronounced standard string, or some people might say stud string. We're using the string class from that standard library, and we're giving the name of this object name. It's a little self-referential, but I asked the person for their name, so calling it name makes perfect sense. So name is a string. You don't know all of what a string can do. You don't need to know all of what a string can do. It can certainly hold strings, and that's what we're going to ask it to do. This line is using standard cin for console input. Another thing in the standard namespace that comes with the standard library. Now, I'm still not discussing the punctuation, but I will just point out that these point in the opposite direction than they did back when we were using cout. And if this makes you think of something going from console input into name, that's exactly how you're supposed to think of it. So this line of code takes whatever it was that I typed on the keyboard and puts it in the string that's being referred to as name. Now we're back to our friend console output, and we're putting out hello, comma, space, and then whatever is in the string name, and then another standard end line. And that's why it came back and said hello Kate to me when it ran. There's no code in this program to pause when we get to the end. As you saw when we ran under the debugger, we didn't pause when we got to the end. The only reason it pauses when you get to the end when you run with Control F5 is because Visual Studio provides that capability for you. So there's no code in the program to pause. The next line in the program is to return. Now when you return from main, you're completely done. You're telling Windows that your application is terminated and it's time to close up the window if that's what the window is launched for. You may notice that tmain starts int space underscore tmain. And int is the return type of that function, just as string was the type of name. Some people wonder why a function like main would bother to return a value or what it could mean, especially in the days of applications, to indicate whether they succeeded or not, for example. It's unusual to see anybody deliberately put a value in the return type of a console application these days, but you can't leave it out. So we just type return 0, and they all return 0, and it all works fine. If you care, 0 actually means success. So you are saying that we succeeded, which I think is fair. Someone typed their name, we said hello to them, we accomplished our mission, and we can return. So the last line of the application is the close brace to indicate the end of tmain. This really is just to keep the compiler happy. When the program is executing, we'll return. But if you left that close brace off, the compiler would say, I don't know where tmain ends, something's gone wrong here, so you have to include it. And that's the structure of our very simplest console application. You can see that we have comments, we're including header files, we're defining our main function, which is what Windows will launch for us when we run the application. We're putting something on standard output using the console output capability of the standard library. We're working with string from the standard library, and we're getting information from console input, again using part of the standard library. If you wanted to take this application and put it on a completely different operating system and use a completely different compiler, you would probably have to change the name from tmain to, say, just main, but it would run properly and work on those compilers and on those operating systems as well. That's the big appeal of C++. There's probably more punctuation on the screen than you're used to seeing, but when we walk through it a line at a time, it shouldn't be too intimidating, and it becomes second nature very quickly. Now that you've seen it a line at a time, it may also be a little bit more readable if we now go back over and take a look at the syntax coloring in Visual C++ Express. You can see that the comments are green, the include directives are blue, and the particular file that they're including is red. You can see that this int and this return are also blue, and these other types are black. They're sort of the meat and potatoes of your application. The strings are in red, helps to make them stand out. This very simple application contains the structure that every console application contains, and once you can read this and write this, you're reading and writing C++.